Before there were stars, planets, or time itself, there was an origin, an instant so brief and inexplicable that even today science struggles to fully decipher it. This audiobook invites you on a 2-hour journey through the most surprising curiosities about the birth of the universe. From the initial spark that ignited it, to the enigmas of space, time, and matter. Why is there something instead of nothing? What invisible forces marked the beginning of everything we know? Each piece of information is a clue to the greatest mystery of all. The beginning of the cosmos. The origin of the universe not only gives us clues about how our existence began, but also confronts us with deeper questions about our own nature. Why are we here? What is our place in the vast cosmos? Each answer we find opens the door to new questions, and in this journey of exploration, every discovery becomes a piece of the puzzle that helps us understand the reality around us. Imagine for a moment that the universe is an immense storybook, filled with captivating tales that we have yet to read. Each page reveals a new mystery, like the spark that ignited the expansion of the cosmos or the enigma of gravity, which keeps us anchored to our planet. But who wrote this book, and what does it tell us about the beginning of everything? By delving into the past of the universe, we not only seek answers but also question our future. When we talk about the mysteries of the origin of the universe, we enter a realm where science and philosophy intertwine. How is it possible for something to arise from nothing? And if the universe began with an explosion of energy and matter, what was there before that? Each theory we explore leads us down a path filled with intriguing questions, where a simple answer can lead us to countless new uncertainties. As we delve into these mysteries, it is essential to remember that curiosity is the driving force behind our exploration. Each unknown invites us to question the world around us and to seek connections between what we know and what is still to be discovered. What is time? And how did it begin to flow in a unique direction? What role do matter and antimatter play in the structure of the cosmos? As we dig deeper into these questions, we realize that the origin of the universe is not just a subject of study, but a journey that unites us all as humanity. So join us on this fascinating journey. We will unravel the mysteries surrounding the origin of the universe, explore intriguing theories, and reflect on what it truly means to exist in this vast and mysterious cosmos. Each mystery is another step toward understanding our place in the universe, and in this quest for knowledge, each of us has a fundamental role. Are you ready to explore the secrets that have accompanied us since the beginning of time? The adventure is about to begin. The universe, as we know it, began with a spark, but what ignited it? The expansion of the cosmos, that phenomenon that gave rise to everything that exists, remains an enigma. Since the moment the Big Bang occurred, a series of questions have arisen, each more intriguing than the last. What caused that initial explosion of energy and matter? Why did everything suddenly begin to expand at an unimaginable speed? So far, scientists have not found definitive answers, and that only increases the mystery. At the heart of this dilemma lies the notion that the universe may have arisen from nothing, but can something really come from nothing? This question has challenged philosophers and scientists for centuries. The idea that the universe was created without any apparent cause challenges our understanding of reality. Could there be an unknown mechanism behind this creation? Or perhaps does nothingness itself have properties we are unaware of that made the birth of the universe possible? Cosmic inflation is another key piece in this puzzle. It is theorized that in fractions of a second after the Big Bang, the universe experienced exponential expansion. But what triggered this sudden expansion? What stopped it? These questions remain unanswered and suggest that there are forces at play that we still do not understand. Gravity, dark energy, and other phenomena may have played a crucial role, but the lack of concrete evidence keeps us in the dark. As we delve deeper into these mysteries, we encounter the enigma of the arrow of time. This phenomenon, which makes us feel that time flows only in one direction, is another aspect we fail to fully comprehend. Why did time begin to move forward at the moment of the Big Bang? Did time exist before that explosion? These questions are fundamental to understanding the very nature of the universe, but the answers seem to elude us. Another fascinating mystery is the origin of something instead of nothing. How is it possible that there is something instead of an absolute void? This question is not only philosophical but also has profound scientific implications. If the universe arose from nothing, what does that mean for our understanding of existence itself? The search for an answer to this question has led many scientists to explore theories that challenge conventional logic. And then the question of gravity arises. Did gravity exist before the Big Bang, or is it a phenomenon that was born along with the universe? Gravity, that force that binds planets and stars, could have origins as mysterious as the universe itself. However, we have yet to define its role in the earliest moments of creation. Moreover, there is an intriguing link between the origin of the universe and its final destiny. Understanding how the universe began could be the key to unraveling how it will end. Could knowledge of its beginning offer clues about its end? This connection between the beginning and the end invites us to reflect on our place in the cosmos and the future that awaits us. The asymmetry between matter and antimatter also raises questions. Theoretically, the Big Bang should have generated equal amounts of both. However, the universe is composed almost entirely of matter. Why did this discrepancy occur? This question has led scientists to explore theories that attempt to explain this peculiarity. But a satisfactory answer has yet to be found. The mystery of space itself is another aspect that leaves us perplexed. How did space-time appear in the initial moment? What generated it and what sustains it? These questions lead us into uncharted territory, where physics and philosophy intertwine in an attempt to understand the essence of the cosmos. The echoes of the Big Bang, those whispers from the past that still reverberate in the cosmic microwave background, hold secrets that could reveal more about the universe's earliest moments. However, despite advances in technology and science, many of these echoes remain an enigma. What are they trying to tell us? Are there hidden messages in those echoes that we have yet to decipher? The origin of the singularity, the point where all the matter and energy of the universe were concentrated, is another part of the puzzle that challenges us. Where did that infinite density that initiated everything come from? The singularity is a concept that defies our laws of physics and leads us into an abyss of uncertainty. When we talk about the first light, we refer to the initial photons that illuminated the cosmos. The creation of that primordial light is a mystery in itself. How was it generated? What conditions allowed for its appearance? The light we see today is the result of complex processes, but its origins remain dark. And finally, we cannot forget the role of dark energy in the origin of the universe. It is unknown whether this mysterious energy was already present at the moment of creation or if it emerged later. Dark energy is one of the greatest puzzles of modern cosmology, and understanding it is vital to unraveling the secrets of the universe. As we explore these mysteries about the origin of the universe, we realize that each answer generates new questions. The pursuit of knowledge is an endless journey, and each discovery brings us a little closer to understanding our existence and the cosmos that surrounds us. The mystery of the origin of the universe is undoubtedly one of the greatest intellectual challenges of our time, and continuing to explore it is essential to understanding our place in the vast and unfathomable universe. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What if I told you that the universe could have emerged from nothing? It sounds incredible, right? However, this is one of the most intriguing theories that scientists are exploring today. But how is it possible that something as vast and complex as the universe could emerge from an absolute void? The idea that the universe may have been born from nothing raises a fascinating dilemma that leads us to delve into the concept of quantum vacuum. First, let's talk about what we understand by nothing. In our daily lives, when we say that something does not exist, we refer to the total absence of matter and energy. But in the quantum world, nothing is much more complicated. In this strange realm, even the vacuum seems to be full of activity. Subatomic particles appear and disappear in the blink of an eye, as if they are playing a game of hide and seek. So, is it really possible that the universe emerged from this dynamic vacuum? Imagine that in this vacuum, where nothing seems to be present, bubbles of energy form that somehow manage to stabilize and expand. This idea has led some scientists to suggest that the universe may have been born due to quantum fluctuations in this vacuum. But here another question arises. What caused these initial fluctuations? Why at a certain moment did one of these bubbles become our universe while others simply faded away? Delving deeper into this enigma, we might ask, what does it really mean to be born from nothing? If the universe truly emerged from a quantum vacuum, then who or what decided it? This is where philosophical and scientific theories come into play. Some believe that the generation of the universe could be a natural phenomenon, while others suggest that there might be a creative principle behind it all. But what evidence do we have to support these ideas? The theory of the quantum vacuum also implies another mystery, the nature of time. If everything began in a vacuum, how did time start? Did time exist before the Big Bang, or did it simply start counting at that moment? This question is deeply intriguing, as it leads us to rethink our understanding of time itself. If time is a construct that arose with the universe, then could there be a before the Big Bang that we still do not understand? Continuing with the thread of questions, let's talk about energy. If the universe was born from nothing, then where did the energy necessary for that initial expansion come from? Some scientists suggest that in the quantum vacuum, energy is present in the form of fluctuations that can give rise to particles and eventually to matter. But how does this translate into the reality we know? Could it be that energy has always existed in a latent state, waiting for the right moment to manifest? As we explore this topic further, we encounter the idea that the quantum vacuum is not a place of inactivity, but a sea of possibilities. Particles can arise and disappear, which raises the question, can entire universes emerge from these fluctuations? Some scientists postulate that our universe could be just one of many, emerging from this very quantum vacuum. But what does this mean for our understanding of reality? Let's put it this way. Imagine you are in an empty room. Suddenly you see a light flickering. That light could be the result of something happening in the vacuum. Now, if we extrapolate this to the universe, we could say that our cosmos is that flickering light, a manifestation of something that was latent in a quantum vacuum. However, this image is just a metaphor. In reality, the magnitude of the quantum vacuum and its implications are much more complex. Let's not forget another crucial aspect, the stability of the universe. If the universe was born from a quantum vacuum, what keeps it existing? Quantum physics tells us that there is a delicate balance between the forces acting in the universe. Could it be that at that primordial moment, conditions were established that allowed for the formation of stable structures such as galaxies and stars? But what guarantees that these conditions will be repeated in other possible universes? As we delve into this vast ocean of questions, it is essential to remember that science is constantly evolving. Theories about the origin of the universe and the quantum vacuum are examples of how our understanding can change over time. New research and discoveries may shed light on these mysteries, and perhaps one day we will unravel the enigma of the quantum vacuum and its relationship to the origin of the universe. In summary, the dilemma of the quantum vacuum invites us to question what we understand about existence itself. From the nature of nothing to the emergence of energy and time, each answer generates new questions. This journey through the mystery of the origin of the universe not only fascinates us but also reminds us of how little we truly know. And in this vast universe of uncertainty, each discovery brings us a little closer to the truth. Are you ready to keep exploring? Cosmic inflation, a concept that sounds complex, is one of the most captivating mysteries about the origin of the universe. But what does it really mean? Imagine a moment when everything we know was concentrated in an infinitely small point. Suddenly, in the blink of an eye, that point expanded exponentially, giving rise to what we now call the universe. This idea is as fascinating as it is perplexing. What could have caused this sudden expansion? Scientists have proposed that for a fraction of a second after the Big Bang, the universe experienced an incredibly rapid explosion. But what triggered that inflation? The answer is not straightforward. There has been talk of energy fields and particles in a quantum state, but the truth is that there is still no consensus. Could it be that something completely unknown was behind this transformation? The search for this answer leads us to rethink our notions of time and space. Another intriguing aspect is that after that expansion, the universe did not stop. What eventually slowed down this dizzying growth? The theory suggests that as the universe expanded, it cooled, allowing the formation of particles, atoms, and later galaxies. However, the forces that intervened in this process remain a mystery. Could there be a mechanism that we have yet to discover that controls this cosmic dance? Cosmic inflation also raises questions about the uniformity of the universe. If everything began with an explosion, why is the universe so homogeneous? That apparent uniformity is astonishing. The theory suggests that, thanks to inflation, the irregularities that might have existed in the primitive universe were smoothed out, creating a more balanced cosmos. But if this is true, where are the traces of those imperfections? As we explore more about cosmic inflation, we find that it has profound implications for the structure of the universe. Why is there more matter in some regions than in others? The theory of inflation could offer us clues about this inequality. However, many of these concepts are difficult to visualize, leading us to wonder, how can we understand something that happens on such vast scales and in such short times? Moreover, cosmic inflation is also related to dark energy, that mysterious force that seems to be accelerating the expansion of the universe today. Could dark energy be an inheritance from that primordial inflation? The idea is intriguing, but we have yet to make the necessary connections. Research on these topics is a journey full of surprises and unexpected revelations. A fascinating aspect of inflation is its connection to the multiverse theory. If inflation was a process that occurred in our universe, what about other universes? Some scientists suggest that our cosmos could be just one among many, each with its own rules and characteristics. What does this mean for our understanding of reality? The questions do not stop there. When thinking about cosmic inflation, we must also consider the role of gravity. How does gravity behave in an expanding universe? As the universe grows, gravity acts to pull galaxies together, but the initial inflation seems to have set the stage in which those forces are in constant play. Could it be that gravity itself behaved differently in those primordial moments? The search for answers leads us to face immense challenges. Scientists are working hard to develop theories that can explain inflation and its impact on the cosmos. However, each discovery raises new questions. Are we closer to understanding the origin of the universe, or are we simply opening more doors to the unknown? In this journey of exploration, curiosity is our guide. Every mystery we unravel about cosmic inflation invites us to dive deeper into the fabric of reality. What other secrets lie in the shadows of expansion? Are we ready to confront them? The mysteries of cosmic inflation are just a part of the puzzle of the universe. But as we reflect on them, we realize that the pursuit of knowledge is as exciting as the discovery itself. Science challenges us to question our beliefs and look beyond the obvious. Are we ready to continue exploring what lies beyond the known? In conclusion, cosmic inflation is a topic that takes us to uncharted frontiers where physics, philosophy, and human curiosity converge. As we continue to seek answers, let us remember that every mystery we solve is just the beginning of another. The universe is a vast ocean of questions, and each wave of discovery brings us a little closer to the truth. The adventure has only just begun. The enigma of the arrow of time is one of the most fascinating mysteries that science has attempted to unravel. Why does time seem to move in only one direction, from the past to the future, instead of the other way around? This question, which may seem simple at first glance, has puzzled philosophers and scientists alike throughout history. The perception of time as a straight line is something we all experience, but when we delve into the realm of physics, things become complicated. The laws of physics, for the most part, are symmetrical. This means that in theory, if we were to reverse time, events could occur exactly the same way, but our reality does not reflect this symmetry. In everyday life, we break a glass, and it is evident that we cannot see the glass reassembling itself into its original shape. So why then do we not see these reversibilities in the universe? What causes time to flow in one direction? One of the most common explanations is the second law of thermodynamics. This law states that in a closed system, entropy or disorder tends to increase over time. Imagine a perfectly assembled puzzle. If you take it apart, it becomes a chaos of pieces. But have you ever seen a disassembled puzzle reassemble itself on its own? That is what entropy implies. The universe tends to move toward a state of greater disorder. However, this only describes how time behaves, not why we perceive it this way. It is curious to think that the time as we know it might be intrinsically linked to the expansion of the universe. As the cosmos expands, time seems to be a companion that moves along with it. But what happened before this expansion? What role does time play in a universe that was, in theory, in a state of singularity where everything was concentrated in a point? This is a question that leads us to reflect on the beginning of everything. Some scientists suggest that time may have begun with the Big Bang, an event that marked the birth of our universe. If this is true, then there was no before the Big Bang, at least not in terms of time as we understand it. But how can we conceive of something that has no before? This opens up a new field of questions that challenge our understanding of reality. On the other hand, time is also related to gravity. Einstein's theory of relativity reveals that time is not constant and can be affected by gravity. In places with intense gravity, such as near a black hole, time slows down compared to places where gravity is weak. Could it be that time itself is influenced by the structure of the universe? What does this mean for our perception of time in a broader context? Moreover, some consider that time is an illusion, a construct of the human mind that helps us organize our experiences. If time is nothing more than a perception, what implications would this have for our understanding of the universe? Could we be trapped in a temporal narrative that does not reflect the true nature of reality? Some philosophers argue that time could be another dimension similar to space. In this sense, time and space would be part of the same fabric of the universe, interconnected and in constant interaction. What if we could see time as we see space? This would lead to rethinking how we experience our existence and how it relates to the universe as a whole. The arrow of time also raises questions about the fate of the universe. If time moves toward the future, where does it lead us? Are we destined for a future where entropy reaches its maximum and the universe cools down, or are there other possibilities? The search for answers to these questions not only helps us understand our past, but also prepares us for what is to come. Reflecting on these issues, it is evident that time is an enigmatic concept that transcends the mere measurement of hours and days. It is a thread that connects events, experiences, and realities, inviting us to explore beyond what we perceive. Ultimately, the mystery of the arrow of time reminds us that there is still much to discover on our journey to understand the universe and our place within it. The nature of time, its direction, and its relationship with the universe remains a fertile field for research. As we move forward, it is important to maintain curiosity and an open mind, as each answer may lead us to new questions. The quest for answers about time is, in itself, an integral part of humanity's journey toward knowledge. So, the next time you look at a clock, remember that time is much more than numbers marking the passage of seconds. It is a profound and mysterious concept that continues to challenge us to think beyond the known. The origin of something instead of nothing is one of the most fascinating and perplexing questions humanity has faced. Why does something exist instead of nothing? This unsettling question has challenged philosophers, scientists, and thinkers throughout history. For many, Nothing seems to be the more logical option. After all, isn't it simpler for there to be nothing rather than a vast universe filled with stars, planets, and life? Yet here we are, in a cosmos brimming with wonders, which leads us to ask, how did we get to this point? One of the most intriguing theories suggests that the universe may have emerged from a state of quantum vacuum. But what does this really mean? Imagine a completely empty space where there is no matter, no light, and no time. Now, according to quantum mechanics, even in that absolute vacuum, there are fluctuations and energies that can give rise to particles. But if the universe began this way, what triggered that initial spark that led it to become everything we know? The idea that something can arise from nothing clashes with our intuition, but quantum physics seems to suggest that it is possible. However, this theory raises more questions than answers. If the quantum vacuum can generate something, then what created it? Why isn't there an alternative universe that never formed? The mind fills with speculation. Some might argue that the existence of a universe is an extraordinary fact and at the same time a miracle. But could it be that the creation of the universe is simply the result of natural laws that we do not yet fully understand? Another philosophical perspective proposes that existence itself is a necessity. In this sense, something has always been part of a broader reality where nothing has no real meaning. This idea presents a view of the universe as an endless cycle where there is always something. But if this is true, what does it mean for our understanding of time and space? Could we be trapped in an eternal loop of creation and destruction? The question of the origin of something also touches the limits of science. There are theories suggesting that our universe is just one of many, a small fragment of a vast and infinite multiverse. In this framework, something could be the result of interactions between different universes. But if this is the case, could we ever come to understand the entirety of this reality? Science, in its quest to unravel the secrets of the universe, faces barriers that seem insurmountable. As we delve deeper into this issue, we encounter the paradox of existence. If something can arise from nothing, that means nothing could be more complex than we assume. Perhaps nothing is not an absolute void, but a state full of possibilities. But how can we prove or refute these ideas? Science is in constant evolution, and what seems like a truth today may be questioned tomorrow. Cultural and religious beliefs have also attempted to address this enigma. Many traditions speak of a creator or a higher force that gives rise to all things. This notion of a creator raises the question of who or what created the creator. It is an endless cycle that leads the human mind into a labyrinth of reflections. Is it possible that existence itself is beyond our understanding? By probing into the origin of something, a range of possibilities opens up. Each scientific discovery brings with it new questions, and each answer seems to generate more mysteries. Thus, the search for truth becomes an endless journey. Are we destined to live in a state of uncertainty regarding our existence? Some might find comfort in this idea, while others might see it as a trap of reason. We might wonder if, in the end, the question of the origin of something is more important than the answer itself. Perhaps it is in the search where the true value lies. Human curiosity drives us to explore, to question, and to discover. Undoubtedly, the desire to understand the universe in its entirety is part of our nature. Ultimately, the question of the origin of something invites us to reflect on our place in the cosmos. If the universe is a miracle, what is our responsibility within it? The awareness of our existence may indeed be the greatest mystery of all. The quest for answers about the origin of the universe leads us to confront our own existence and to question what it means to be human. As we continue to explore the far reaches of the universe, the question of something will remain a beacon guiding us. It reminds us that, even if we do not have all the answers, curiosity and the desire to understand are powerful forces that unite us. Thus, the pursuit of knowledge becomes a shared journey that transcends time and space, inviting us all to participate in this great mystery. Who knows what discoveries await us in the future? The story of the universe is still a blank page, ready to be written. Gravity is one of the most fundamental forces in the universe, but its origin is a true enigma. Did gravity exist before the Big Bang, or was it a product of that crucial moment? This question has intrigued scientists and philosophers for decades. Since we began exploring the cosmos, we have discovered that gravity is not only responsible for the attraction between objects, but also influences how the universe expands and structures itself. However, its nature remains a mystery. One fascinating aspect of gravity is its relationship with time. How is it possible for gravity to affect time itself? In the context of Einstein's theory of relativity, we understand that time is not a constant. It dilates or contracts depending on the gravitational force surrounding it. But what happens at the moment when the universe began to expand? Did time make sense at that moment? Or did time as we know it emerge with gravity? Every time we look at the sky and observe the stars, we can see how gravity acts over vast distances. Galaxies rotate, solar systems form, and black holes devour everything around them. But how did this powerful force originate? Some scientists suggest that gravity might have arisen from quantum-level interactions, but this raises more questions than answers. Is it possible that gravity is a manifestation of something even more fundamental that we have yet to identify? And if gravity emerged at the very moment of the Big Bang, what caused it? The idea that this force could have been present before the beginning of the universe challenges our current understanding. Could there have existed a pre-Big Bang state where the laws of physics were completely different? This speculation leads us to think of a universe that, despite being infinitely small and dense at its inception, already contained the seed of gravity. Speaking of density, let's consider another mystery. How can it be that gravity, a force that seems so omnipresent, arose from a singularity? In its origins, the universe was a point of infinite density and temperature. How can a force like gravity emerge from such an extreme state? This paradox invites us to question the very nature of gravity. Is it really a force, or is it a manifestation of the curvature of space-time caused by mass? Furthermore, what role does gravity play in the evolution of the universe? From the moment the first particles formed to the creation of stars and galaxies, gravity has been a key player. However, could it be that gravity also has a limit to its influence? Are there forces that can surpass it? The answer to these questions is crucial for understanding the ultimate fate of the universe. The search for a theory that unifies gravity with quantum mechanics has been a goal in modern physics, but why is it so difficult? When trying to apply the rules of quantum mechanics to gravity, we encounter contradictions. Is it possible that gravity, being such a different force from the others, requires a completely new approach? As we delve into the study of gravity, we also encounter the issue of dark energy. This mysterious form of energy seems to be accelerating the expansion of the universe, but does it have anything to do with gravity? Could dark energy be a component that works in conjunction with gravity, or is it a completely independent force? The story of gravity is not just a tale of forces and effects, it is also a philosophical journey. It leads us to question our place in the cosmos and to reflect on the nature of reality itself. Is gravity a universal constant? Or could it be different in other universes? Could we be living in a cosmos where the laws of gravity behave differently? As we ponder these mysteries, it is important to remember that science advances through questions. Each discovery about gravity brings us closer to a deeper understanding of our universe. But will we be able to solve the enigma of the origin of gravity, or will this mystery remain hidden, challenging future generations of scientists and thinkers? Gravity keeps us anchored to the ground, but it also invites us to look beyond. It reminds us that while we may understand many aspects of the universe, there will always be questions that push us to keep exploring. What other surprises does gravity hold for us in the future? What discoveries are yet to come? The search for answers continues, and each new finding could change our understanding of the cosmos. As we advance in our exploration of the universe and its mysteries, gravity will remain a central theme in our investigations. Undoubtedly, its origin and role in the cosmos are just the tip of the iceberg. The quest for the truth about gravity may lead us to discover unexpected connections and open new doors in our understanding of the universe. So the next time you look at the starry sky, remember that every star, every galaxy, and every corner of the cosmos is influenced by this fundamental force. What new questions will arise in our quest to unravel the mystery of gravity? Only time will tell. The origin of the universe is not only a fascinating mystery in itself, but it also invites us to reflect on its destiny. Why is it so important to understand how everything began? The answer may be deeper than it seems. By exploring the beginning of the cosmos, we can unravel the laws that govern it and glimpse its end. But can the beginning of something really give us clues about its end? From the moment the Big Bang erupted, the universe has been in constant expansion. But what does that mean for our future? If we understand how it formed, we might guess where it is headed. The history of the universe is also the story of its destiny. Could it be that the very processes that gave rise to stars and planets are connected to their eventual disappearance? The expansion of the universe leads us to think about dark energy, that mysterious force that seems to be accelerating the expansion. Is it possible that this energy has played a crucial role from the beginning? If dark energy existed at the moment of the Big Bang, it could be the key to understanding not only how everything began, but also how it will end. What implications would this have for our existence and the future of humanity? Every time we look at the night sky, we encounter a universe in constant change. But can we predict what it will be like in millions of years? Some scientists suggest that understanding the origin of the universe could give us clues about its destiny. Could it be that in the life cycle of the cosmos there is an end similar to the Big Bang, or are we destined for endless expansion? Questions about the fate of the universe are not limited to physics. They also touch on philosophy. What does the end of the universe really mean for us as conscious beings? If we understand that the cosmos has a beginning and possibly an end, how does that affect our perception of time and life? Is every moment we live part of a larger story that transcends us? As we delve into this topic, we encounter the asymmetry between matter and antimatter. This imbalance has led to the creation of a universe filled with stars and galaxies, but it also raises questions about its destiny. Why is there more matter than antimatter? If the universe had the same amount of both, what would our fate be? Would we be destined for an end where matter annihilates with antimatter? Gravity plays a fundamental role in the fate of the universe. What would happen if gravity behaved differently? If it were to change at some point, we could face a cosmic collapse or infinite expansion. How can we predict these events? Gravity is not only responsible for holding planets and stars together, but it could also be the key to understanding the life cycle of the cosmos. Black holes, those mysteries of the universe, also have a role in this story. What happens to the matter that falls into them? Some scientists suggest that they could be gateways to other universes or even to the past. Could these phenomena be part of the cycle of creation and destruction in the cosmos? Or do they simply swallow everything and leave us with more questions than answers? The exploration of space offers us a unique insight into our place in the universe. As we discover new planets and star systems, the question about the fate of the universe becomes even more intriguing. Are there other worlds that could be our home in the future? If the universe continues to expand, will it be possible for humanity to find a new place to survive? The search for answers leads us to the multiverse theory, which suggests that our universe might be just one among many. What does this mean for our destiny? If there are other universes, could they be experiencing different endings? The idea of a multiverse also opens the door to the possibility that the end of our universe is not definitive, but merely a transition to something new. As we reflect on the destiny linked to the origin, we cannot ignore the role of time. How is time related to the cycle of the universe? Some scientists propose that time as we know it only began with the Big Bang. What does that mean if we consider that time might not exist in a universe before this event? Are we really trapped in a timeline, Or is there a deeper cycle of which we are still unaware? The quest for answers about the origin and fate of the universe leads us to question our own existence. Why are we here? What purpose does our life have in a universe that might have an end? Exploring these questions helps us better understand not only the cosmos but also our own humanity. So as we continue to probe the mysteries of the universe, let us remember that each answer leads us to new questions. The connection between the origin of the universe and its destiny is a journey full of enigmas, where each discovery brings us closer to understanding not only the cosmos but also our place within it. As we move forward in this quest, it is essential to keep curiosity alive and never stop questioning. In the end, the true mystery of the universe may be the search itself for answers. The asymmetry between matter and antimatter is one of the great mysteries surrounding the origin of the universe. To understand why it is so intriguing, we first need to break down what matter and antimatter are. Imagine that every particle of matter we know, such as electrons and protons, has a counterpart in antimatter. The electron has its equivalent, the positron, which is identical in mass but has an opposite charge. In theory, when matter and antimatter meet, they annihilate each other, releasing a tremendous amount of energy. But what happened to all that antimatter? The question we ask is, why is there so much more matter than antimatter in our universe? According to current theories, at the moment of the Big Bang, equal amounts of both should have been created. However, in the universe we observe today, matter seems to have won the game. What could have happened in that fragile balance that tilted existence to one side? Some scientists suggest that in the early moments of the universe there was a slight imbalance. This imbalance, although minimal, may have been enough for matter to prevail. But how was that small margin achieved? This is a puzzle we have yet to solve. Physicists are exploring various theories, from fundamental interactions to possible new particles that could have influenced this process. Let's consider what it would mean to have an equal amount of antimatter. If we suddenly found a planet completely made of antimatter, what would happen? The mere contact with our matter world would cause a massive explosion. This scenario leads us to the next question. Why haven't we found signals of antimatter in the universe? Although antimatter has been produced in laboratories and detected in certain cosmic reactions, its presence is extremely scarce in the cosmos. Scientists have theorized that there could be regions of space where antimatter exists, but so far we have not had direct evidence. Some theories suggest that in a parallel universe there might be more antimatter. However, this leads us to another fascinating question. Could there be a universe made entirely of antimatter in some corner of the multiverse? If so, what kind of life could inhabit it? Some researchers have proposed that gravity could play an unexpected role in this asymmetry. It could be that gravity, which attracts matter, interacts differently with antimatter. This would open a new field of study, questioning whether antimatter could behave in a way we do not yet understand. Could it be that gravity acts differently in the case of antimatter? Throughout history, the discovery of new particles has changed our understanding of the universe. For example, the existence of neutrinos, tiny particles that hardly interact with matter, has challenged us to rethink how antimatter behaves. If the universe is full of secrets, the search for antimatter is like a cosmic treasure hunt. What else could we discover if we managed to understand its origin and scarcity? The theory of symmetry, which suggests that the laws of physics should work the same for matter and antimatter, also comes into play. However, observations of phenomena in the universe have shown that this symmetry does not hold entirely. What does this mean for our fundamental laws of physics? Are we facing the need for a new theory to explain this deviation? Experiments in particle accelerators, such as the Large Hadron Collider, seek answers. In these laboratories, scientists are trying to recreate the conditions of the early universe. Could it be that by studying particle collisions, we will unveil the secret of the asymmetry? Perhaps through these experiments we will understand how the forces of the universe worked together in those early moments. Meanwhile, the possibility that antimatter could be used as an energy source remains a topic of debate. If we could find a way to produce and store antimatter, we could be on the brink of an energy revolution. However, the risks are enormous. In fact, the very idea of manipulating antimatter brings with it ethical and safety dilemmas. Are we ready to play with forces that could destroy worlds? The asymmetry between matter and antimatter also invites reflection on our own existence. If the universe had created equal amounts of both, perhaps we would not be here. Could it be that our very life is the result of a cosmic whim? Science offers us answers, but it also raises questions about our place in the universe. Philosophers have wondered whether this asymmetry has implications beyond the physical. Is it possible that the existence of matter and antimatter reflects a deeper order in reality? Perhaps in its quest for balance, the universe is teaching us something about the duality of life itself. With each discovery, science brings us one step closer to solving the mystery of the asymmetry. But at the same time, it reminds us that there is still much to explore. The search for answers drives us to continue probing the secrets of the universe. In the end, isn't this curiosity what defines us as human beings? The asymmetry between matter and antimatter is just one of the many questions waiting for us in the vast and intriguing cosmos. How did space itself come to be? It is a question that has fascinated scientists and philosophers alike. When we think about the origin of the universe, we often imagine explosions, stars being born, and galaxies forming. However, there is an even deeper mystery. How did the space-time in which all this occurs come into existence? Without space, there is no place for the history of the cosmos to unfold. But where did that space come from? The Big Bang Theory tells us that about 13,800,000,000 years ago, everything we know began to expand from an extremely hot and dense state. But what was there before that? Some physicists suggest that there may have been nothing at all. However, that idea is difficult to grasp. How can there be nothing? What if space itself is just an illusion? Another intriguing question is, did space always exist, or did it begin to exist along with the universe? If space is something that was created, what initiated it? Current theories fail to provide definitive answers. There is talk of the possibility that space formed with the expansion of the universe, but that raises more questions. What does it really mean for space to have been born? And how can something be born from nothing? The concept of vacuum is also perplexing. In physics, the vacuum is not simply an empty space. Instead, it is a place filled with possibilities and quantum fluctuations. But if the vacuum is full of potential energy, then why was there nothing before the Big Bang? This leads us to question the nature of the vacuum. Is it really empty, or just a way to describe a state we do not fully understand? Moreover, if space is the container of the universe, what holds it? Is there something beyond our observable universe that shapes this space? Some scientists have proposed the idea that there could be other dimensions or realities, but if there is something beyond our universe, what implications does that have for our understanding of space and time? Additionally, what about the curvature of space? Einstein's theory of relativity tells us that gravity can bend and curve space. But how does that relate to the birth of space? If space can curve, does that mean it could be flexible, changing? And if so, does that suggest that there could have been a before the Big Bang in a form we still do not understand? Another fascinating issue is that of black holes. These enormous objects are said to alter the structure of space-time and in some cases could even act as portals to other places in the universe. If black holes can alter space, then what kind of power do they have over its creation? Could they somehow be a key to understanding the origin of space? We cannot overlook the idea that space might have a purpose. Since time immemorial, humanity has sought meaning in existence. Is it possible that space has a reason for being, a purpose that we have yet to discover? This thought may seem philosophical, but it aligns with the scientific curiosity that drives us to explore the mysteries of the universe. And of course, what about time? If space was created at the very moment of the Big Bang, what happens to time? Did time exist before the Big Bang, or did it start counting at that moment? This poses a dilemma. Is time a consequence of space, or are they independent entities? The relationship between the two is an unexplored territory that could hold answers to many of our questions about the origin of the universe. Furthermore, is it possible that the structure of space we know is just a phase in a larger cycle? Some scientists postulate that our universe could be just one of many in an endless cycle of expansion and contraction. If this is true, what does that mean for the nature of space? Could it be that space resets in each cycle, as if it were in an endless wheel of creation and destruction? Finally, let us reflect on the role that observation plays in our understanding of space. The way we measure and perceive space can influence how we understand its origin. As our technology advances, our ability to explore the universe expands. What discoveries are yet to come, and how will they change our perception of space and its creation? In conclusion, the mystery of how space itself came to be is an enigma that invites us to delve into the nature of reality. Each question we pose opens the door to new possibilities and explorations. As we continue to investigate and question, perhaps one day we will uncover the secrets of space and its origin, allowing us to understand not only the cosmos but also our place within it. What echoes resonate in the vast silence of the universe? In the cosmic microwave background, messages from a past we are just beginning to understand are hidden. This mysterious glow is like a fingerprint of the Big Bang. A revelation that leads us to ask, what does it really tell us about the origin of the cosmos? Imagine a moment when everything we know did not exist. From that nothingness, the initial explosion created not only matter and energy, but also space and time. However, what is fascinating is that this echo, which manifests as radiation, is the only window we have to observe the conditions of the primitive universe. But how can we decipher its secrets? The cosmic microwave background was discovered accidentally, a coincidence that has become one of the cornerstones of modern cosmology. But what does this mean for us? Each photon of that radiation has been traveling through space for over 13 billion years, bringing us a message from a time when the universe was young and hot. What story do those photons tell us? Measurements of this radiation reveal that the universe is surprisingly homogeneous and uniform. But curiously, it also presents small variations like tiny wrinkles in a sheet. Why do these fluctuations exist? These small differences could be the seeds of all the structure we observe today: galaxies, stars, and planets. Could it be that within those small irregularities lies the key to understanding how the cosmos formed? Now let's think about the temperature of this radiation. At the moment of the Big Bang, the universe was extremely hot, and as it expanded, it cooled down. Today, that temperature has dropped to less than 3 degrees above absolute zero. But why is this information so important? The temperature provides us with clues about what the universe was like in its early moments. However, the question remains, why has this cooling been so uniform throughout the cosmos? The existence of the cosmic background radiation also poses an intriguing enigma. Why does the universe seem so balanced? The amount of matter and antimatter should have led to their mutual annihilation. However, it seems that there is more matter than antimatter. What could have caused this asymmetry, and how is it related to the cosmic background? As we delve deeper into this topic, we encounter another mystery. Although we have been able to measure cosmic radiation, there are still aspects we do not fully understand. Current theories do not completely explain the characteristics of this radiation. Could there be unknown phenomena influencing what we observe? The cosmic background radiation also offers us a glimpse into the first moments of the universe, a time when matter had not yet formed complex structures. But what happened in those early moments? The lack of understanding about physics under extreme conditions leaves us with more questions than answers. What laws of physics were at play in those initial moments? Some scientists suggest that cosmic radiation is an echo of the Big Bang itself, a reflection of the energy released in that crucial moment. But what does this mean for our understanding of creation? If the radiation is a fingerprint of the past, could it also be a guide to the future of the universe? As we advance in our exploration, we find the need for a new physics that can unify general relativity with quantum mechanics. Could this new theory help us better understand the cosmic background? The search for a theory that explains these phenomena reminds us that there is still much to discover and that each answer can open the door to new questions. The cosmic background radiation is not only a remnant of the past, but also offers us perspectives on the future of the universe. As the cosmos expands, how will this affect the radiation we observe? Could the future reveal secrets we cannot yet imagine? In conclusion, the cosmic microwave background is much more than a simple remnant of the Big Bang. It is a window into a distant past and an enigma that challenges our understanding of the universe as we continue to explore these echoes. Each discovery brings us a little closer to understanding not only the origin of the cosmos, but also our place within it. What other secrets does the universe hold for us? The search for answers continues. And each question that arises is another step toward understanding the mysteries that surround us. Where does the singularity that initiated our universe come from? This question has puzzled astronomers and physicists for decades. At the heart of this uncertainty lies the notion that, at the moment of the Big Bang, everything we know was concentrated in a point of infinite density. But how is it possible for something to arise from such an extreme and mysterious state? To understand this enigma, we must consider what a singularity really means. In simple terms, it is a point at which the laws of physics as we know them cease to function. But how did we arrive at this critical point? What conditions or forces were present in the primordial universe that allowed a singularity to form? Let's imagine the singularity as a starting point, a spark in the darkness. However, what ignited that spark? Some scientists suggest that the singularity may have existed forever in a state of infinite potentiality. But if that is true, why have we not been able to observe it? Why are there no visible signs of its existence? Moreover, when discussing the singularity, we face another mystery, the transition from this infinite density to an expanding universe. How did the universe move from a state of extreme compression to one where galaxies are separating and space is expanding? This transformation is as fundamental as it is perplexing. Einstein's theory of relativity provides some clues, but it is still not enough. General relativity describes how gravity affects matter and space, but it does not address what occurred at the exact moment of the singularity. Is it possible that we need a new theory that combines relativity with quantum mechanics to unravel this mystery? At this point, it is interesting to consider the role of energy in the creation of the singularity. Some scientists believe that dark energy, a mysterious force thought to be behind the accelerated expansion of the universe, may have played a role in the formation of the singularity. But how could this energy be part of such a primitive state? Black holes also offer a fascinating window into the singularity. In these cosmic phenomena, matter collapses into an extremely dense point, creating its own singularity. Could it be that studying black holes helps us better understand the singularity of the Big Bang? Might they contain clues about how the universe began? As we delve deeper into this mystery, we also encounter the question of causality. What triggered the singularity? Was there a before the Big Bang that helps us understand how we reached that point? The notion of time as we know it may not apply in that initial phase. But if time did not exist, how can we talk about cause and effect? Mathematical models and simulations are vital tools in this quest. Through them, scientists attempt to reconstruct the early moments of the universe, but the singularity remains an obstacle. Is it possible that we may never fully understand this phenomenon? Is the singularity a limit to our knowledge? And here arises the deepest question of all. If the singularity is the origin of everything, what does this mean for our understanding of reality? The idea that everything we know comes from a point of infinite density challenges our most basic notions about the universe. Are we prepared to accept that there are limits to what we can comprehend? As we advance in our exploration of the universe, it is crucial to keep an open mind. The singularity and its origin are more than just a scientific puzzle. They reflect our curiosity and desire to understand the cosmos. Are we willing to accept that there are things that may remain hidden forever? Ultimately, The mystery of the singularity invites reflection and speculation. It reminds us that despite our advances, there are still fundamental questions that remain unanswered, and perhaps in that search for answers we truly find the meaning of our existence in this vast universe. So, in contemplating the origin of the singularity, we are not only exploring the beginning of our universe, but also the limits of our understanding. What other secrets lie hidden in the depths of the cosmos, waiting to be discovered? The answer to that question could be the driving force of our journey toward knowledge. In the vast cosmos, an enigma shines with a mysterious light, the origin of the first light. What illuminated the newly born universe for the first time? Scientists have been searching for answers to this question for decades, trying to unravel the moment when darkness dissipated and light began to flow. But how can something so fundamental remain such a deep mystery? To understand this phenomenon, it is crucial to go back in time to a moment very close to the Big Bang, when the universe was extremely hot and dense. At that time, light as we know it could not exist. The particles were so energized that they simply could not form atoms. So, what happened for light to appear? The key seems to lie in a process called recombination. A few 100,000 years after the Big Bang, the universe began to cool. This allowed electrons to combine with protons and form hydrogen atoms. But why is this so important? By forming atoms, matter was able to stop being in an ionized state, which allowed photons or particles of light to move freely. Before this moment, light had been trapped in a sea of charged particles. So was it at this instant that light could finally shine? Scientists believe this event marked the release of the light we know today. However, this initial light was not like what we see now. It was a primitive and hot version, a flash of radiation that has traveled through the cosmos for billions of years. In this context, another intriguing question arises. How can we today observe these echoes of the first light? The answer lies in the cosmic microwave background, a kind of echo of the Big Bang that can be detected everywhere in the universe. This background radiation has become a treasure for astronomers, as it contains information about the state of the universe in its early moments. But what secrets does it hold? What does it tell us about the nature of that first light? As we explore the cosmic microwave background, we find patterns and fluctuations that reveal much about the structure of the universe. But despite all the knowledge we have accumulated, the question persists. Why did light begin to flow at that particular moment and not before? What specific conditions made the appearance of photons possible? One of the most fascinating theories suggests that quantum fluctuations in the primordial state of the universe may have influenced the creation of these first particles of light. Perhaps in the chaos of the birth of the cosmos, small irregularities in the density of matter led to the first emissions of light. But what does this mean for our understanding of quantum physics and the universe in general? Light not only represents a physical phenomenon, it also symbolizes knowledge and curiosity. When we talk about the first light, we talk about the first hints of what could be life itself. Light is essential for the existence of stars, planets, and ultimately, life as we know it. But what implications does this have for the future of our exploration of the cosmos? As we advance in our quest for answers, it becomes evident that each new piece of the puzzle leads us to more questions. Could it be that the light we see today contains information about the ultimate fate of the universe? What will it tell us about its expansion and eventual collapse? The search for the first light is not only a journey into the past, but also an exploration of our future. It is important to remember that each discovery in this field not only expands our understanding of the cosmos, but also connects us to our own existence. The light that illuminated the universe billions of years ago is still part of us today. Isn't it amazing to think that in some way we are all part of that story? Finally, although the mystery of the first light remains unresolved, it invites us to keep exploring. Science is a path full of intrigue and surprises, and each new answer raises more questions. The search for the truth about the origin of light is ultimately a quest for our place in the universe, So as we continue to question and explore, let us remember that each flash of light connects us to the vast and mysterious cosmos. The story of the first light is just the beginning of a narrative that continues to unfold, a tale that invites curiosity and exploration. What other secrets does the universe hold for us? The search has begun, and only time and human ingenuity will reveal what is yet to be discovered. When we look at the vast universe that surrounds us, many questions arise, and one of the most intriguing is, what role does dark energy play in the origin of everything we know? This enigmatic component seems to be invisible, but it is believed to be responsible for approximately 75% of the total energy of the universe. However, its nature remains a true mystery. But how can something we cannot see have such a profound impact on the creation of the cosmos? Let us imagine for a moment the instant of the Big Bang. It is a moment that marked the beginning of our universe, but was dark energy part of that initial explosion? Some scientists suggest that this energy may have been present from the beginning, acting as a kind of force that drove the expansion of the universe from its earliest moments. But where does this dark energy really come from? Is it a phenomenon inherent to space itself, or is it something more complex? As we explore this question, we find that dark energy not only affects the growth of the universe, but also raises new inquiries. For example, if dark energy was present from the start, does this mean that the universe has always been expanding? Or could it be possible that there was a moment when this energy was different, perhaps even absent? This idea leads us to reflect on how understanding the past of the universe could change our perspective on its future. The concept of dark energy invites us to think about the very nature of emptiness. Is what we see truly empty? Or could it be that within that emptiness lies a form of energy that we do not fully understand? Some theories suggest that quantum vacuum, a state in which particles can appear and disappear, might be related to dark energy. But how can we reconcile these seemingly contradictory concepts? As science advances, new theories emerge that attempt to explain dark energy. One of them is the idea that it could be an intrinsic property of space, a fundamental trait of the universe. But this leads us to a troubling question. If dark energy is woven into the fabric of space, could its existence be tied to the very creation of the universe? Is it possible that dark energy is the engine that drives not only expansion but also the birth of new cosmic structures? Let us take a moment to reflect on the future of the universe. If dark energy continues to influence expansion, what awaits us in billions of years? Some scientists predict that the universe could continue expanding indefinitely, while others suggest that at some point there could be a change in this dynamic. But what could trigger a change in dark energy? Are we talking about an endless cycle of expansion and contraction, or is there an inexorable end in sight? Every answer we find about dark energy generates new questions, making its study so fascinating. For example, if dark energy is responsible for the acceleration of expansion, could it be that it has a connection to gravity? Could it be that as the universe expands, gravity and dark energy intertwine in ways we have yet to decipher? This interconnection could be key to unraveling the secrets of the cosmos. We might think that in seeking answers about dark energy, we are exploring not only the origin of the universe, but also the limits of our knowledge. Each theory and each discovery reminds us of how little we know about what surrounds us. Is it possible that in our quest for truth, we are merely scratching the surface of something much larger and more complex? The question of dark energy's role in the origin of the universe is also linked to the search for a unified framework that explains all the forces of nature. Could it be that by understanding dark energy, we are also one step closer to comprehending quantum gravity? This challenge has intrigued scientists for decades and reveals how interconnected the mysteries of the cosmos are. Dark energy, then, is not just an abstract concept. It represents the frontier of our understanding and pushes us to explore beyond the known. In every discovery, every new finding, we face a reality that is both awe-inspiring and perplexing. Can we imagine a future in which we manage to unravel the secrets of this mysterious energy? If so, what implications would it have for our understanding of the universe and our place within it? As we continue to explore these questions, it is essential to remember that the path to truth is filled with uncertainty. Every step we take in researching dark energy is an invitation to question our assumptions and to open our minds to new possibilities. Perhaps we will never come to know all the answers, but the journey itself is what propels us forward, pushing us to discover what lies beyond the stars. In conclusion, the mystery of dark energy is a reminder of the wonder and complexity of the universe. It invites us to keep exploring, to question, and to marvel at the unknown. Who knows what revelations await us in the future? All we can do is continue searching, with the hope that perhaps one day we will unravel the true role of dark energy in the origin and evolution of the cosmos. The search for a theory that unifies gravity with quantum mechanics is one of the great challenges of modern physics. Why is this search so important? Gravity, which keeps planets in orbit and shapes massive structures like galaxies, seems to behave in a completely different way than the subatomic particles that govern quantum mechanics. How is it possible that two such fundamental forces behave in such distinct ways? This disconnect leads us to profound mysteries about the very nature of the universe. Einstein's theory of relativity has provided us with an extraordinary understanding of how gravity works on a large scale. However, as we approach the microscopic world where quantum mechanics reigns, things become complicated. What if we could combine these two theories into one? The result could be a more complete description of how the universe began and how it functions. However, so far, scientists have failed to find a theory that achieves this unification. One of the questions that arise in this context is, what happens at the heart of a black hole? In the core of a black hole, gravity becomes so intense that even light cannot escape. How do the laws of physics behave in that extreme environment? General relativity suggests that the curvature of space-time becomes infinite, but quantum mechanics tells us that there cannot be infinite density. This dilemma poses a deep mystery. How do we reconcile these two realities? Another intriguing question is the existence of quantum gravity. Is it possible that a theory already exists that explains how gravity and quantum mechanics interact? Some scientists propose that quantum gravity could be the key to understanding events like the Big Bang or the formation of black holes. However, so far, we have not been able to directly observe the effects of this theory in action. This leads us to wonder, what kind of experiments could provide us with clues about this union? The search for a theory of quantum gravity also involves delving into the concept of space-time. Is space-time a continuous entity, or is it made up of quantum bricks? Some theories suggest that at extremely small scales, space-time could be granular, like a kind of mosaic. How could this change our perception of the universe? If space and time are discontinuous, the implications for our understanding of the universe are astounding. Additionally, there is the question of quantum fluctuations. In the context of the early universe, could these small variations have influenced the formation of large-scale structures? Quantum fluctuations might have sown the seeds of galaxies and stars, but are they really responsible for the organization of the universe as we know it? This is an active area of research that continues to generate debate among physicists. Quantum gravity could also help us address the enigma of singularity. How can we understand the initial state of the universe, where all matter and energy were compressed into an infinitely dense point? This is a monumental challenge as the known laws of physics cease to apply at those extremes. What new laws might exist that could help us understand this primordial state? As we explore these mysteries, one question persists. Could quantum gravity have implications for our understanding of time? If gravity and quantum mechanics were united, perhaps time itself could be different in those early moments of the universe. Is it possible that time as we know it did not exist in its current form before the Big Bang? The idea of unifying gravity with quantum mechanics also opens the door to speculations about the multiverse. If our universe is just one of many, could there be universes where the fundamental forces behave differently? This possibility leads us to ask, what does it really mean to exist in a multiverse? As we continue to seek answers, quantum gravity presents itself as both a promise and an enigma. Could it be the thread that leads us to a deeper understanding of the universe and its origins? As scientists continue to explore, they face the monumental task of unraveling these mysteries that have challenged generations. Ultimately, the search for a theory that unifies gravity with quantum mechanics is not just an academic exercise, it has profound implications for our understanding of the universe and our own existence. What discoveries lie ahead? The history of physics is full of surprises, and the future may reveal secrets we have yet to imagine. Are we on the verge of unraveling one of the greatest mysteries of all time? Time will tell. What are primordial quantum fluctuations? This question takes us to an intriguing territory in the search for the origin of the universe. Imagine a scenario where, in the most absolute vacuum, unexpected events occur. In this context, quantum fluctuations are like tiny bubbles of energy that appear and disappear in the blink of an eye. But why are they so relevant for understanding how our cosmos was formed? The theory suggests that these fluctuations, although fleeting, could have left a mark on the structure of the universe we know today. But how is it possible that something so tiny influences the vastness of the cosmos? The answer lies in the fact that, in the early moments after the Big Bang, the universe was extremely small and dense. In that environment, even the most subtle fluctuations could have a disproportionate impact. But how do these fluctuations translate into what we see now? It's as if, in a sea of possibilities, a small change in the energy pattern could have sown the seeds of galaxies, stars, and planets. Each of those energy bubbles could have been a spark, a small brick in the vast construction of the universe. However, the question remains, were these fluctuations really responsible for the structure we observe today? Scientists face a dilemma. On one hand, quantum fluctuations are a well-documented phenomenon in physics. On the other, the link between these fluctuations and the formation of large cosmic structures is not entirely clear. We have yet to decipher how exactly quantum chaos translates into the order of the observable universe. Is it possible that the same principle governing the behavior of subatomic particles has an effect on a cosmic scale? The answer seems to be a puzzle we have yet to piece together. While some physicists argue that quantum fluctuations are key to understanding the distribution of matter in the universe, others continue to seek alternative explanations. Could it be that instead of being the sole answer, fluctuations are just part of a much larger picture? The debate on this topic remains alive, and each new research brings more questions than answers. Imagine that each galaxy in the universe is like a tree in a forest. Quantum fluctuations would be the seeds that, under the right conditions, can germinate and grow. But what are those conditions? What allowed those small variations to become such enormous structures? These are the kinds of questions that take us to the frontier of human knowledge and understanding of the cosmos. The idea that the universe could have originated from small fluctuations in a quantum vacuum is exciting, but also puzzling. If these fluctuations could give rise to everything we see, what does that mean for our understanding of reality? Are we talking about spontaneous creation? Science often finds itself at the intersection of philosophy and physics, and this is a perfect case of that. Moreover, the mystery doesn't end there. Quantum fluctuations also lead us to consider the concept of chaos and order in the universe. In simple terms, quantum chaos could be the seed of cosmic order. But how is that order established from chaos? This is another question that invites us to delve into the mysteries of nature. Some scientists have proposed that if we manage to understand quantum fluctuations, we could open a door to a new paradigm in physics. Could we, in the future, use that knowledge to unravel other mysteries of the universe? The possibility that these tiny bubbles of energy could provide answers to broader questions is a fascinating path. The journey towards understanding primordial quantum fluctuations is thrilling, but also filled with challenges. Quantum physics, by its very nature, is complicated terrain. The rules that govern the subatomic world often defy our intuition, making the task of connecting those rules with the vastness of the universe a monumental challenge. In the end, primordial quantum fluctuations are like echoes from a time when everything began. Although we do not have all the answers, each discovery brings us a little closer to unveiling the mystery of how our universe was formed. The search for truth in this field invites us to keep exploring, to question what we believe, and to open our minds to new possibilities. So, as you immerse yourself in the vastness of the cosmos, remember that the small things, often overlooked, may hold the greatest keys to existence. The adventure of discovering how primordial quantum fluctuations could have shaped our universe continues, and each new revelation invites us to keep asking and exploring. In this journey, each satisfied answer may open the door to even more questions, keeping the spark of wonder alive in the pursuit of knowledge. When discussing the origin of the universe, a fascinating question arises. Did time exist before the Big Bang? This question has puzzled scientists and philosophers alike, as it leads us to explore the limits of our understanding of reality itself. If we consider that the Big Bang was the moment everything began, we face an intriguing paradox. If time began with the Big Bang, what would before that event mean? Let's imagine for a moment that time is like a flowing river. What happens when there is no river, no flow, not even a bank? Without time, there would be no past, present, or future. But then, how can we conceive of before if there is no temporal framework to anchor our ideas? This is one of the reasons why many consider the question of time before the Big Bang to be a dead end. However, some theorists suggest that time may not be linear. Could it be that time, as we understand it, is an illusion? Perhaps the universe and time are part of a more complex whole where our perceptions are limited. If time did not exist before the Big Bang, could it be that it has always existed in a different form? Or that it is destined to be cyclical, repeating in an eternal loop? One of the theories that has captured the imagination of many is that of time as an additional dimension, similar to spatial dimensions. In this context, time could be just one aspect of the fabric of the universe. What would this mean for our understanding of the past and the future? It would mean that time could be something more than a simple sequence of events. It could be a multi-dimensional landscape that we do not fully comprehend. As we delve deeper into this mystery, we find that some scientists propose the idea that time may have had a primordial existence. Imagine a time that existed before the time we know, where the physical laws were different. What would happen to our notions of cause and effect in such a universe? This challenge leads us to re-examine everything we believe about causality. However, the notion of a before remains problematic. If it is accepted that the Big Bang marked the beginning not only of the universe but also of time, we face the difficult task of imagining a state of existence where time was not a factor. How can we talk about events or processes without the temporal structure that frames them? Philosophers have explored this issue for centuries, and some argue that the idea of before is inherently human, a construct of our minds that attempts to organize experience. But what about the laws of physics? Are they also a product of our perception of time? The answers to these questions could change our understanding of reality. As science advances, models have been proposed suggesting that time may have been part of a cosmic cycle. In this framework, the universe expands and contracts in endless cycles. Does this mean that time, in a certain sense, is eternal? And if so, how does this relate to the singularity of the Big Bang? Black holes also play an intriguing role in this discussion. Some researchers believe they could offer clues about the nature of time and space. By exploring what happens inside a black hole, we might find answers that help us understand how time behaves under extreme conditions. Could it be that time behaves differently in these environments? In the realm of quantum physics, time also takes a different turn. Subatomic particles seem to challenge our conventional notions of time and causality. Could it be that time, on the smallest scale of the universe, operates in a completely different way than we perceive in our daily lives? The quest to understand time before the Big Bang also poses a philosophical challenge. How can we reconcile science with our beliefs about time? As we explore these questions, we realize that science and philosophy are not enemies, but allies in the pursuit of truth. The possibility that time is an illusion or that multiple temporal dimensions exist opens up a world of possibilities. Are we ready to accept that our understanding of time may be just a small part of a much larger puzzle? As scientists continue to investigate, each new revelation brings us one step closer to unraveling this enigma. In conclusion, the question of time before the Big Bang is a mystery that invites us to question our most fundamental beliefs. As we explore the possibilities, we find ourselves at the intersection of science and philosophy, a place where questions are as valuable as answers. The pursuit of knowledge about our origins connects us all, reminding us that although time may be an ephemeral concept, our curiosity to understand it is eternal. The multiverse theory is one of the most fascinating and controversial proposals within modern cosmology. What if our universe is not the only one? What if there are thousands, millions, or even infinite universes, all coexisting at the same time, but in dimensions we cannot see? The idea that our cosmos is just one among many has captivated the imagination of scientists and philosophers alike. Imagine a vast ocean of universes, each with its own physical laws, its own constants, and perhaps even its own forms of life. In this context, the Big Bang would not be the absolute beginning of everything, but simply the birth of our particular universe. But where do these other universes come from? Could they have originated from an event similar to the Big Bang, or are they rather independent bubbles in a sea of realities? Some physicists suggest that the multiverse could be the result of cosmic inflation, a period of extremely rapid expansion that took place shortly after the Big Bang. During this process, small fluctuations could have given rise to different regions of space-time, each developing uniquely. But what does this mean for us? If we live in a multiverse, how does that influence our lives and our understanding of the cosmos? An intriguing question is whether these parallel universes could interact in some way. Is it possible that there is an echo of other universes in ours? Some theories suggest that we might be able to detect the influence of other universes through anomalies in cosmic radiation or in the structure of our space. However, so far we have not found concrete evidence to support this idea. Another fascinating aspect of the multiverse is the possibility that there are universes where conditions are completely different. In some of them, the laws of physics could be radically different, which could give rise to forms of life that we cannot even imagine. What does this mean for our conception of life and intelligence? Are we alone in the vast cosmos, or are we just one of many forms of existence? As we delve deeper into the multiverse theory, profound philosophical questions arise. If there are infinite universes, what does that mean for free will? Does it mean that in some alternative universe, all the decisions we could make have already been made? The notion that each choice could generate a different universe raises ethical and existential dilemmas that have been the subject of debate for centuries. The multiverse also challenges our understanding of reality and existence. If other universes exist, what makes them real? Are they as valid as ours? And how can we study something that, in principle, could be completely beyond our reach? Science, in its quest to understand the nature of the cosmos, faces limits that seem unbreakable. Some scientists have proposed that although we cannot directly observe other universes, we might find indirect evidence of their existence through particle physics or cosmology. For example, certain patterns in the cosmic microwave background radiation could be traces of collisions with other universes in the past. However, so far, these ideas remain in the realm of speculation. The notion of a multiverse also opens the door to creativity and imagination. In popular culture, it has inspired countless science fiction stories, where characters travel between different realities and experience alternate worlds. These narratives are not only entertaining, but also invite us to reflect on the nature of existence and the diversity of the cosmos. As science advances, the multiverse theory remains fertile ground for research. Scientists like Max Tegmark propose that parallel universes are a natural consequence of the mathematics that describes our reality. From this perspective, the existence of other universes is not only possible but inevitable. Are we ready to accept that we live in a multiverse? The multiverse theory also raises questions about the origin of the laws that govern our universe. If there are other universes with different physical laws, what determines the characteristics of each one? Can this be attributed to an underlying principle that governs the creation of universes, or are they simply products of chance? In recent decades, the idea of the multiverse has gained acceptance in certain scientific circles. Although it remains subject to criticism, some argue that, being so difficult to prove or falsify, the multiverse theory might be more a matter of philosophy than of science. However, its ability to open new avenues of thought and explore the unknown is undeniable. Ultimately, the multiverse theory invites us to look beyond what we consider possible. It challenges us to question our assumptions about reality and to consider that what we know might be just a small part of something much larger. In this vast and enigmatic ocean of universes, the search for answers about our place in the cosmos continues, and perhaps one day we will decipher the secrets that connect us to those other worlds. The universe, as we know it, began with an explosion of energy and matter that gave rise to everything that exists. But have you ever wondered how it could have started in such an orderly way when everything we know about physics tells us that chaos is more common? Here arises a fascinating enigma, the problem of initial entropy. This concept may sound complicated, but it is actually a simple question. Why did the universe start with such an improbable order? Entropy is a measure of disorder in a system. In simple terms, systems tend to move toward a state of greater disorder. So if we look around us, we see that things tend to break down to become disorganized. Why then did the universe begin in such an organized manner? This is one of the most intriguing questions facing scientists. Imagine the beginning of the universe. Everything was concentrated in an extremely small, dense, and hot point. Suddenly this point explodes and begins to expand. But here lies the dilemma. Most scientific theories suggest that in such a dense state, entropy should be incredibly high. However, the universe began with a remarkably low level of entropy. How is that possible? You might think this is due to the nature of the Big Bang, but the truth is that we still do not fully understand why the universe began in such an ordered state. Was there some unknown force or mechanism that allowed for this initial organization? Could it be that, as the universe emerged, the laws of physics we know did not yet apply in the same way? Physicists have proposed various theories to explain this paradox. Some suggest that the universe may have started in a state of equilibrium. But that raises another question. What does equilibrium really mean at a moment when time as we know it did not yet exist? How can we talk about equilibrium in a context where the dynamics of the universe were just beginning? Imagine we are in a vast ocean of possibilities. Before the Big Bang, everything was in a kind of primordial soup. But how was such a specific and ordered initial state chosen? This choice presents a dilemma. If the universe began in such an improbable way, what are the implications for our theories about the origin and future of the cosmos? One of the most intriguing theories suggests that the universe could have been part of a larger process. Something occurring in a multiverse. If there are multiple universes, each with different properties and levels of entropy, perhaps our universe is simply one of the few that started with such peculiar order. But how can we test this idea? The answer remains elusive. The question of why the universe began with a low entropy state also leads us to reflect on our place within it. If the initial order was so improbable, what does that mean for us and our lives? Are we destined to be a rare phenomenon in a sea of chaos? This idea can be unsettling, but it can also be inspiring. As we explore the origin of the universe, we realize that each answer generates new questions. Could it be that the universe, in its vast complexity, is trying to tell us a story that we do not yet fully understand? The search for answers about initial entropy leads us to question our own perceptions of reality. Initial entropy is not only a puzzle for physicists but also a philosophical challenge. Questions about order and chaos, time and space force us to reconsider what we know about the universe. Is it possible that the universe is shaped by something beyond our current physical laws? What invisible forces might be at play? As we continue our quest for answers, we find comfort in curiosity itself. Science is a journey, and each mystery unraveled brings us a little closer to the truth. So, when you think about the problem of initial entropy, remember that it is not just about numbers and theories, but about the story of our universe, a story we have only just begun to understand. This dilemma about initial entropy is a reminder that, although we may feel small in the vastness of the cosmos, our questions are significant. The search for truth is an endless journey, and every step we take brings us closer to unveiling the secrets of the universe. In the end, initial entropy invites us to keep exploring, to keep questioning, and to keep marveling at the immense and fascinating complexity of the cosmos we inhabit. What do we really know about the origin of the universe? As we delve into the mysteries that have intrigued humanity for centuries, it becomes evident that every answer generates new questions. Why are we here? What led us to exist in this vast cosmos? The exploration of these enigmas is not only an intellectual exercise, but a quest that touches the deepest fibers of our curiosity and our existence. The history of the universe is, in many ways, the story of a journey that began billions of years ago and continues to unfold today. However, the beginning of this journey remains a chapter filled with shadows and speculation. What happened in that primordial moment that gave rise to everything we know? The notion of a beginning is both fascinating and perplexing. Let us reflect on emptiness and nothingness. If the universe could arise from nothing, how can nothing give rise to something? It is a dilemma that has challenged philosophers and scientists alike. The ability to create something from nothing seems to defy all logic, and yet here we are. What forces or principles could have allowed such a phenomenon? The idea of cosmic inflation offers an intriguing clue, suggesting that in the early moments after the Big Bang, the universe experienced explosive expansion. But what triggered it? And most importantly, what stopped it? These questions lead us to question the very nature of time and space. If time began with the Big Bang, could there have been a prior state that we still do not understand? The asymmetry between matter and antimatter is another of those enigmas that leaves us perplexed. Why, in a universe that should have created equal amounts of both, do we only find matter? This discrepancy leads us to question the fundamental laws of physics and to seek explanations that go beyond what we know. Is there a type of matter that we have yet to discover? If the universe has a destiny, could it be intrinsically linked to its origin? Understanding how everything began could be the key to unraveling how it might end. This cycle of birth and death is a recurring theme in the history of the universe, but what does it tell us about our own future as a species? Gravity, that force that keeps us anchored to the Earth, is itself a mystery. Did it exist before the Big Bang, or was it a consequence of its initial explosion? Gravity not only affects objects, but also shapes the very structure of the cosmos. As we inquire into its origin, we wonder how many other forces might have emerged at that crucial point. The echoes of the Big Bang, those whispers trapped in the cosmic microwave background, are fascinating. They tell us a story. But do we truly understand what they are saying? Each signal is a clue that could bring us closer to answering fundamental questions about our origin. However, what we still do not know is whether those echoes hold secrets we will never decipher. And what about the singularity that initiated everything? The infinite density that existed at that initial point challenges our understanding of physics. How can one conceive of a state in which the laws of physics as we know them do not apply? This enigma invites us to reconsider our understanding of reality itself. Light, that phenomenon that illuminates our world, also has its own mysteries. How were the first photons generated that began to light up the cosmos? The first light is a symbol of hope and knowledge, but at the same time it is a reminder of how little we truly know about the beginnings of everything. Dark energy, that mysterious force that seems to drive the acceleration of the universe's expansion. also raises unsettling questions. Was it already present at the beginning, or did it form later? The quest to understand its role is fundamental to unraveling the future of the cosmos and our own existence within it. The concept of time before the Big Bang challenges logic. If time as we understand it began at that moment, what does that mean for the reality of what existed before? The idea of time outside our frame of reference is difficult to imagine, but it is crucial for understanding the entirety of our history. Finally, the theory of the multiverse takes us into even more intriguing territory. Could our universe be just one of many? If so, what implications does that have for our identity and our place in the cosmos? The idea of an infinity of universes offers a horizon of possibilities, but also raises more questions than answers. As we reflect on all these mysteries, it becomes clear that the pursuit of knowledge is an endless path. Every answer we find leads us to new questions, and every discovery opens up a new range of possibilities. The exploration of the origin of the universe is more than mere curiosity. It is a search for our place in the vast and intricate fabric of existence. So let us continue questioning, exploring, and above all, marveling at the immensity of the cosmos and the mysteries that still await our discovery.